Hey everybody, and welcome to Module 7. We have made it so far in the semester. We're almost there. And with me today, we have our special guest, Dr. Abel. Thank you so much for joining us this time, Dr. Abel. And as always, we have our math guru, Nicholas.
Hello, everybody.
Hi.
Thank you for having me, Janine.
Of course. Thank you for being here.
Yeah. Nowhere else I'd rather be.
Okay, so let's get into it. Module 7 scenario. We're going to be going over and doing another ADIME, another scenario with a non-complicated, very low birth weight infant and dealing with enteral nutrition, parenteral nutrition, and it's going to be really fun. It's going to be a cool one.
They always are.
They always are. So, Dr. Abel, can you tell us a little bit about what we're going to be needing here in regards to, all of our normative data, or just little like key tips in regards to the scenario? What should we know before we get into this?
Well, in the first couple of slides are the normative data that we have been presenting since Module 1 even. So this information should look familiar. Most of it is based on the weight of the baby. So in our scenario, I believe this little baby Jackson is 880 grams. So you're going to want to look at the protein requirements and the energy requirements for an 880 gram infant and the growth velocity for an 880 gram infant. And those will be very important that you understand. So as we're moving through the scenario, we are really beginning to be part of the team that rounds together, and you're going to be giving specific advice based on this normative data to the team as far as what they want to do next to reach these advisable goals.
So really quickly before we move on, the normative data goes, from ranges of 700 to 900 and 900 to 1200. So if there are 880, would we focus on, the bottom tier or the higher tier for normative data?
Yeah, that's a great question. And as you can see in the protein, it's exactly the same, right? 4 to 4.5. And it's really only 1 calorie per kilogram difference. So they're going to be pretty close. But to kind of help you with that thought, if the baby is growing kind of rapidly and gaining weight quickly, there'd be nothing wrong with thinking ahead for the normative data of the next weight group. That would be very appropriate to do. But we still, these are guidelines. These are not standards. These are not absolute numbers, that this is the only number that we want to reach. The baby will actually tell you how they're growing and what is best for them. So looking at that rate of weight gain based on what the actual intake, both parenteral and enteral, it will be important. And in this data, I just want to remind you that this is enteral nutrition. We're going to need the guidelines for parenteral nutrition as well.
Okay.
Great question.
Well, you brought up rate of weight gain, so let's go ahead and tackle rate of weight gain. So this is just an example. We're going to be using it a little later on, and we've done this before several times, but this time we're going to do it a little bit differently, especially right here. We're focusing on the denominator. We're just going to use an average weight instead of just basing it on the current weight. And that's because in this case, there's such a big difference between the current and previous weight. So this is just a kind of more accurate method to do rate of weight gain. So up here, we have the 2 steps in the process with 2 equations. So we're just going to take the example we have and plug them into the equation and see what the rate of weight gain actually is for this example. So starting with the first step, we are going to do the current weight in grams, which is 1400, minus the previous weight in grams of 1100. And divide that by the number of days between weights. So you'd subtract the dates, but we have it given to us here. So we're going to divide that by 14 days. And that's going to give us 300 grams in 14 days for a total of 21.4 grams per day. But we want this answer in grams per kilogram per day, so we're not going to stop there. This is where we start with the second part of the equation. And to do that, we're going to do 21.4 grams per day divided by the average weight in kilograms. So to find the average, we need to add them up and divide it by 2. So we have 1,400 grams, which is 1.4 kilograms, plus 1.1 kilograms, and divide that by 2. And this would give us 21.4 over 1.25 kilograms. And that math will round out to 17.12 grams per kilogram per day. So that's the rate of weight gain over this specific time span. Okay?
Makes sense. Okay, and guys, this is nothing new. Again, like Dr. Abel was saying, this is just our normative data that you're always going to be referencing in these scenarios. And remember, these are just guidelines and not standards, but they are here for your reference. So this is the advisable intake for very low birth weight infants. And then here we have our comparison of the nutrition provision. So this is protein per 120 kcals per kilogram per day. And then you have all the different types that we've seen before. We know that we've used unfortified breast milk. We've been using the Similac with the human milk fortification. We've been using the Similac, the special care high protein. So this should be nothing new. And remember that all of this information is always found in the Similac website. When you actually Google the actual formula that you're looking for, those websites, or the Enfamil website, the Mead Johnson website, will give you all of these values. So if you need more information, you can always go and reference that as well.
And let me just interject something. I want you to notice on this slide that this is actually per 120 calories per kilogram. And when you actually go on the website, it'll be per 100 calories per kilogram. And in previous modules and tips, I've given it to you, or Janine and Nicholas, I've given it to you per 100. So just pay attention to those units. It's very important that when the numbers look a little different, it's because it's per 120, not per 100 calories per kilogram.
So this is actually something that we kind of calculated out then, right? Because normally the websites will only give per 100 calories.
That's correct.
Okay.
Yes.
I think our next slide is also per 100 calories. Yeah.
Yes.
This would be the information that you can find on the actual website.
Yes. Very good.
Okay, some more normative data. This is our little feeding protocol, if you will. And this is something that you should always reference to as well in regards to, the day of life and where they should be kind of at, to normally use as a guideline when we're going through these scenarios and rounding on these babies in actual clinical practice. Remember that every hospital has their own feeding protocol, so you would be using your hospital's feeding protocol.
Yeah. And this is a great tool. If you go back, just you can, depending on the day of life. So just to give you an example, in our particular nursery, like we would look at day of life and see where they were as far as enteral nutrition. And if they weren't at 60 meals per kilo of enteral nutrition, we would start to ask questions and investigate why. And it really does help you, because the goal is to get the full feed. These babies have less comorbidity, they have less complications. So the quicker we can get them to full feeds, they'll usually have a shorter length of stay in the hospital and less complications. So I'm going to turn this over to Nick.
Yeah, we're just going to start off more kind of review, just finding out the percentiles and z-scores of the infant's growth using PD tools. So we have another example of how to input it here. So if you were to do that, you would get the right answer, tested and true. But make sure to follow along with us and do it yourselves, just so you get the hang of it. So for this specific date, The infant's birth weight was in the 28th percentile with a z-score of negative 0.6, with a length in the 24th. And the head circumference in the 22nd percentile with a z-score of negative 0.79. So again, we've done this before, but we're just doing it one more time to review with you. Now here we're going to do something a little bit different. We're going to calculate the percent of weight loss. So as we can see, if we look at the birth weight and the current weight, that's the infant has lost 10 grams, not 10 pounds. So it's not there's no weight gain, there's weight loss instead. So we just want to calculate the percentage. So what we're going to do is figure out the difference between the current weight, the previous weight and the current weight, which is a 10-gram difference. And then we're going to divide the 10 grams by the birth weight, which is 880 grams. And that's going to give us about 0.01. And if we were to convert that value to a percentage, we would just move this decimal over twice, and that would be 1%. Alternatively, you can multiply that, you can multiply that times 100, and that would give you the 1% as well. So the current percent weight loss in this case is 1%. So what do you ladies think about the appropriateness of this weight loss?
Well, it's very important that you even understand this. All babies, whether you're a term or a premature baby, lose weight. We are really expecting a regain of birth weight in a term infant around 7 days. And in a premature infant, it could be anywhere from 7 to 10, maybe even up to 15 days. And the nadir is where just we hit the bottom and then we start to gain weight. So on day of life 6, we really don't want to see a weight. We want to see it less than 8 to 15%. So this is absolutely wonderful, 1%. This baby is healthy and has already started to gain back their birth weight, or headed in that direction. They've hit nadir and they're headed back to gaining weight.
Okay, well, what was it that you said normally they start to regain at what day of life?
A term, it's around 7 days, and a preterm, it's around 10 to 15 days.
Okay.
So this is day of life 5, and they're only at 1%. So we like to see it under, by day of life 6, we like to see that percentage less than 8 to 15%. So that's kind of the guidelines there.
Okay, less than 8 to 15%.
On
This
day of
is
life.
doing very well.
Yes.
Yeah, so
Is this indicative of why this would be a non-complicated, very low birth weight infant?
Right. Yeah. So this baby is, even though they're small, everything seems to be working for them.
Okay, that makes sense. Because you see weight loss and you immediately think, oh no, but that's not the case, right?
Yeah, it's very normal. So even you that are moms and have ever had a baby, your baby will lose weight during that first week of life.
Okay, so then let's go ahead and continue here. So here is where the more heavy math starts, but again, we've done this before. So the first thing, this is our PN order. So it's ordered at a rate of 4.2 milliliters per hour. And we want to see what the volume is going to be with that rate for the whole day. So if it's at 4.2 milliliters per hour, we have, of course,
24 hours in a day.
Thank you. 24 hours in one day. So that's going to give us 100.8 milliliters per day, right? But
guys, just to reiterate before Nick goes on, make sure that you guys are going along with us and writing this along, because practice makes perfect. and you don't want to end up in a situation where you get confused because you didn't practice with us. So get out your pen and paper. I'm getting out my pen and paper and my calculator, and I'm going along with Nick too.
Good job, Janine. Good advice.
So like I was saying, we have milliliters per day here, but we want that value in milliliters per kilogram per day. So since it's a per, we're just dividing by the kilograms, and this infant is at 880 grams, which if we divide by 1,000, we know that's 0.88 kilograms. There are 1,000 grams in a kilogram. So the total rate in this case would be 115 milliliters per kilogram per day. Okay, now we're going to take a look at the nutrients within the PN, the bag, and see what value in terms of calories are going to provide us based off of the amount of these nutrients. So we're going to start first with the amino acids. So we have 4 grams per kilogram of amino acid. And we want to know what that would give us in calories per kilogram. So Janine, I'm going to ask you again.
I knew you
You're
were
not getting
gonna
away
ask
this
me.
time.
You're always
How
gonna
many
trip me up.
calories of amino acids are, well, how many calories are in 1 gram of amino acids?
4.
4. Okay, so we want to cancel out the grams. So we're going to put that on the bottom. So 1 gram of amino acids is 4 calories. And that's going to give us 16 calories per kilogram of amino acids.
Mm-hmm.
Okay, and then we're going to move on to the glucose infusion rate to find the calories from dextrose, which is a little more complicated, but not all that complicated. So let's just write this out again. So we have the 10 milligrams per kilogram per minute of dextrose. And we have kilograms per minute, but we want it in kilograms per day. So we're going to try to get rid of the minutes. So we know that there are 60 minutes in 1 hour. But if we do this math right here, we're going to get it in hours per kilogram, or rather milligrams per kilogram per hour, which is still not what we want. We want it in per day. So we want to get rid of this hours too. So we're going to multiply that by how many hours are in a day. We have 24 hours. And once we have all of our units written out here, we can easily cancel them out. So the minutes here are going to cancel, and the hours here are going to cancel. And we're going to be left with just the numerical math here, which gives us 14,400. And that is the units you have left, which is milligrams of dextrose.
1440. Right? Oh, times 10. You did times 10.
That's
okay.
why practice makes perfect.
See, guys? Okay, yes.
And then we have the
got it.
kilogram left and the days left. So milligrams of dextrose per kilogram per day. Okay. But of course, we're not done there. We want it in calories, not milligrams. So what we're going to do, let me just rewrite this. Okay, what we want to do is convert that to grams of dextrose first, because our calories are in, per gram, calories per gram. So again, we're going to get rid of the milligrams. We're going to put it at the bottom so that they cancel. And for every 1,000 milligrams, there is 1 gram. And that gives us 14.4 grams of dextrose per kilogram per day. Okay, Janine?
I got it.
Tell me. How many?
Oh
How many
my God.
calories per gram?
Oh, for per
of
gram of
dextrose?
dextrose.
Yes.
3.4.
3.4.
You guys, we've done this so many times. It really, if you don't have it memorized by now, I don't know.
Try to
practice
memorize
at
it
home.
by now.
Make some flashcards and do it with yourself because we need to know this.
Yep. Again, we're putting grams on the bottom to cancel them. And that is going to give us approximately, we're going to just round it out already, 49 calories per kilogram per day from dextrose. And then lastly, just our lipids, which is another easy one.
How many now? Oh, we have 3 grams.
So how many is that, Janine? Per
10.
gram calories? You
10.
said 10, not 9.
Not 9.
Not 9.
10.
That's going to give us 30 calories per kilogram per day. Okay.
Okay.
So we just want to add that all up here. So we get 16 plus 30 plus 49, which is a total of 95. Okay, so this order at this rate would give us 95 calories per kilogram per day.
But again, this was what's on the order, but is it what is actually being given?
Well, Dr. Abel, is this what they're going to be getting?
That's a great question. And even before I answer that question, I just want to mention that if you are asked how many amino acids are ordered, your answer would be the 4 grams per kilogram. Sometimes students get that confused, even though it's right there in front of them. So what happens is the physician orders this amount, and the order goes to the pharmacy, and the pharmacy literally puts together the bag of liquids that have 4 grams of amino acids and 3 grams of lipids and 10 milligrams per kilo per minute of dextrose. And so that solution is put into a bag, and the bag is brought to the baby and hooked up with an IV going into the central vein. But then what happens is the physician actually needs to order an amount to actually be infused. So they make a decision not to infuse the full 4.2 mils per hour, but they'll infuse a different amount, and for a variety of reasons why they may do that. So in this particular example that we're going over with you, the doctor actually now has ordered to only have 3.2 of this order being infused into the baby. So you need to think of it as a percentage of what we just calculated. And I'm going to turn this back over to Nicholas to explain how to obtain that percentage of what 3.2 will mean as far as your calculations as a dietitian that you will be putting into your ADIME note.
Thank you, Dr. Abel.
Just to clarify though, Dr. Abel, so normally, well, is this something that you can find in the chart, correct? Like in their medical record, you'll see the order, for example, like at 4.2, but then you'll see the actual infusion rate as like 3.2?
Yes, you'll see both of them in the order. And it's very common understanding as you work in a NICU. I would imagine this also occurs in the adult population as well, because not everything ordered can always be infused for a variety of reasons. So yes, you will see the order of the parental nutrition, and then you'll see just how it's written there, order to be infused at whatever rate. So even in an hour, the doctor can come back and order to be infused 2.6. So then you would recalculate your numbers again. So the nurses follow that. Then they actually have a dial on the where it's being infused into the baby's vein, and they will dial it to 3.2. So only that amount can be infused into the baby's artery.
Got it. Okay, let's move on.
So
lots of math in the NICU, right?
Yeah.
So much math.
More than we expected. So like Dr. Abel said, we're going to calculate what this infant will be receiving based off of the order that's actually being infused, which is 3.2 milliliters per hour. And she brought up percentages, which is exactly how we're going to do it. But there's 2 ways to do it. The first way is with proportions, which I hope you all like by now. And the other way is the percentages, which are easier. So we're going to show you both. But before we do any of that, we need to figure out what the volume is that this infant is going to be receiving based off of the rate of 3.2 milliliters per hour. So this is just like we did it before. We need to know That's per hour. We need to know for the whole day. So there are 24 hours in one day. And that's going to give us 76.8 milliliters per day. But of course, we need it in kilograms per day. So we're just going to divide that by the kilograms of this infant, which is the 0.88, for a total of 87 milliliters per kilogram per day. Okay. So now that we have that, we can see how many calories are going to be getting based off of the nutrients that are in that bag. So we're just going to start with the proportions, a little old school first, and then we'll do the percentage method, which is a lot quicker and a lot easier, but less fun. So the proportion, we're going to take what we just got from the previous slide, which is 95 calories per 115 milliliters per kilogram per day. And we want to equate that to the same values, but with a different volume. In this case, the volume is going to be what we just calculated. And we're looking for the calories. So we're going to cross multiply here, and that's going to give us 115x. Remember to keep your units, milliliters per kilogram per day, times these units right here, the calories per kilogram per day, equals this little bit of cross multiplication, which gives us 8,265 calories per kilogram per day times the milliliters per kilogram per day. Okay, so remember here we're looking for the x calories per kilogram per day. So we're going to solve for x on this left side. And to do that, we need to get rid of the number. So we're going to divide by 115. But we also want to get rid of the units. So we need to get rid of the milliliters per kilogram per day. We divide both sides by that value. In doing so, these will cancel out. These will cancel out. And that's going to give us 72 calories per kilogram per day. Okay, so that's our answer there. Now we're going to take a look at the protein and figure out how much protein the infant's going to be receiving based off of these nutrients in the bag. So it's the same process, it's another proportion. So we're going to do the 4 grams that we got from the previous slide. And equate that to the amount of calories, or rather, sorry, the volume from the previous prescription. It's equal to the volume that we are currently using. And on top here is X. So that's what we're looking for. We're going to cross multiply again. And we're going to have 115 x milliliters per kilogram per day times the calories per kilogram per day equals the 4 times 87, which is 348. And that's going to be grams of protein per kilogram per day times the milliliters per kilogram per day. And real quickly, I just realized this is not calories. It is grams of protein. See, we all make mistakes.
Units, the units. Pay attention to your unit.
Yep.
Yeah, very important.
Okay, so then again, we just want to solve for x. So we're going to get rid of the 115. And we want to keep the grams of protein. That's what we're looking for. So to keep the grams of protein, we're going to get rid of the milliliters. By both sides. And then these are going to cancel. And that's going to give us a total of 3.0, approximately, we rounded, grams of protein per kilogram per day. Okay,
Yep.
so that's how we would solve it using proportions. But now we're not going to use proportions. We are going to do the percentage method. So to do that, we're going to take these two numbers, the 3.2 and the 4.2. So we know that since it's going to be at 3.2 instead of 4.2 now, that is less than the 4.2. So it's at a lower percentage that they're going to be receiving. So let's just figure out what that ratio is, what that percentage is. So that we're just going to do 3.2 divided by the 4.2 will give us 0.76. Units are going to cancel. So that is the ratio that we're working with here. Okay. So if we wanted to figure out the difference in calories based off of this ratio, then we would take that initial calories that we had, which was 95, and multiply it by this ratio here, the 0.76 or 76%. Just remember that if you're using like percent, then you don't multiply it by 76. You have to put it into decimal form, which is 0.76. And that's going to give us 72 calories per kilogram per day. And that is the same as up here. So it's a lot quicker. It's easier. It's still fun enough. So if this method works for you, go for it. And I believe is this one that's used more often, Dr. Abel?
Absolutely, yes.
Yeah, okay. So now that we have that, let's go ahead and do the protein. Remember to do it along with us. So same process. Since the rate hasn't changed here, it's the same ratio that we're going to be using, that 0.76. But this time we're going to take the protein from before. So we have 4 grams of protein per day times that same ratio, which would give us, lo and behold, 3 grams of protein per kilogram per day. Okay, so it's easier. It's more commonly used. So make sure to know both methods, just in case you forget one, at least you have the other.
Okay, so just to reiterate, guys, we normally, when we're talking about parenteral nutrition, we always want to stick to amino acids, not necessarily protein, because that's what's being given. Remember, we said a couple modules back, when you're using parenteral nutrition, this is being given in the bloodstream. That's why it's already broken down protein, which is amino acids. So we did use protein here, but remember, you should always preface it with amino acids, especially when you're in clinical practice. That's the way that it should be correctly done. Nick, right. You did catch that. I will give you credit. You caught yourself. And we all make mistakes, guys. Pay attention to your units.
Yeah, that is, if you learn anything from this module, just at least that's enough for me. So then I guess, well, like Janine said, it'd be 3 grams of amino acids per kilogram per day, not protein. But with that, let's move on to the next slide here, where we are going to be looking, or we're going to be looking at enteral nutrition instead. Okay, so here we have unfortified breast milk at a rate of 4 milliliters Q3 hours, which is a total of 8 feedings, because Q3 hours means every 3 hours. There are 24 hours in a day. 24 divided by 3 is a total of the 8 feedings there. Okay, so the first thing that we want to do here is take that rate and see what that's going to give us in terms of milliliters per kilogram per day, because that's what we work with here. So we're going to take the 4 milliliters times the 8 feedings. It's going to give us 32 milliliters per day. And we're going to divide this by the kilogram of the infant, because we want it in milliliters per kilogram per day. So we're at a total of 36 milliliters per kilogram per day. Okay. So now that we have that, we want to figure out the calories and the protein that the infant's going to be receiving based off of, using unfortified breast milk. So we see here that we have 20 calories per ounce, and we know that that's not what we're going to use to solve this. We deal with it in calories per milliliter, not calories per ounce. So we're going to go ahead and do that conversion here. So right now we have 20 calories in 1 ounce, and we want to get rid of the ounces. So we're going to put the ounces on top. And then how many milliliters are in an ounce, Janine?
30.
30.
30 milliliters.
30 milliliters. Never forget it. So that just leaves us with 20 divided by 30, which is approximately 0.67 calories per milliliter. Okay. So now that we have this value, we can solve for the kcals. So we're going to take the volume of 36 milliliters per kilogram per day and multiply that by the 0.67 calories per milliliter. Okay, and our milliliter is going to cancel once, we're going to cancel, and that leaves us with just 24 calories per kilogram per day. Okay, and then from here, we can also go ahead and calculate the protein. This time there are no percentage form, so sucks for you, you have to go for the proportions. That's why you can't forget it. And in this case, we're gonna have 1.34 grams of protein per 100 kcals, because that is what the amount of protein that's present per kcal within unfortified breast milk. Okay, so we're going to equate that to what we just found to be, to what we're missing, which is the grams of protein per kilogram per day, over what we just found to be 24 calories per kilogram per day. Okay, so we're going to cross multiply here. Once again, 100x kcals times grams of protein per kilogram per day equals this multiplication right here, which gives us 32.16 grams of protein times calories per kilogram per day. Okay, and once again, in this case, we're looking for the grams of protein per kilogram per day. So on the left side, we want to keep that much and the x. So we're going to divide it by 100 kcals and this side as well. When we do that, these cancel here. These cancel. And we are left with 0.3 grams of protein per kilogram per day. That's our x value. So it's that simple. That's why you cannot just rely on one method. You need to know both of these.
Mm-hmm.
Okay.
Just to reiterate, the actual 1.34 grams of protein comes from the actual normative data that was in our charts previously. So make sure that you guys make sure to reference that, have that handy while you're doing these proportions. Also, Dr. Abel, I did want to ask you a question. So we're doing both of them because this baby is going to be receiving both, right? PN and EN.
Simultaneously, this is how it works. Before you can get to full feed, you have to gradually start out in small volumes to see how the baby's tolerating it.
So this is
this is how it works in an uncomplicated baby, right? So every time you round, you would be increasing the volume and decreasing the parental nutrition. And that's why the feeding protocol is so helpful, because if you actually look at the feeding protocol, that's exactly what it does. And it gives you the combined total of what is the guidelines for that particular hospital.
Got it. Okay. What next, Nick?
Well, that is it for this slide. So if we can move on. So here, like Dr. Abel and Janine just talked about, we're doing enteral nutrition and parenteral nutrition at the same time. So we need to figure out, combined, what is what's going to be the intake of this baby. So all these numbers here and here, we just calculated in the past few steps. So all we're going to do is add them up together and see what the total EN and PN values are going to be. So for the volume first, we're going to add the 87 and the 36 for a total of 123. Our calories, we're going to have the 72 and the 24, which gives us 96 calories per kilogram per day. And for protein, we have our 3 grams from parenteral and 0.3 from enteral, for a total of 3.3 grams of protein per kilogram per day. Okay.
Great. And on the ADIME note, you'll actually list out what you're giving with the parental nutrition, and you'll list out the enteral, and then you'll have a line with the totals. So as we move forward, we'll see that.
Okay, so this was our total. And as Dr. Abel just said, this is why the feeding protocol is so important, because you definitely want to have this as your reference to see where this baby's kind of really falling within the actual feeding protocol. So how would we read this here? So basically we have our volume, which is at 123. And what was the day of life? There was day of life 5, right?
Yes.
Right, we're on day of life 5, so you'll want to go down to that
Day of life 5 right here.
Yeah.
And so our volume is at 60.
That's what our goal should have been.
That's the goal. And so in volume is 100 run at 80 milliliters per kilogram per day. And then the total of EN and PN fluid should be about 140. So that's still a little low, right, Dr. Abel? Ours is at 123.
Ours is inadequate. So where is it inadequate? Is the EN at 60? And is that what's causing us to be low? So you would want to look at each line item. So let's look at EN. It's 36 mils per kilogram, and it should be at 60.
At 60, yeah. So we're definitely lacking there.
Yeah.
And then our PN is really kind of on point because it should be run at 80, and we're at 87.
Yeah. So.
Okay. So
that's why our total would be low, probably because of the enteral nutrition, not because of the PN, right?
Right. And they could, if there is a complication with the baby, they really need to run the parental nutrition at a higher volume. So even in this case, this is explaining this particular case, why it's being run at 3.2 instead of 4.2, the parental, because we're increasing the enteral. And so we make the parental nutrition at that higher volume, just in case they have a problem with the enteral, and you could just then turn the volume up to 4.2 and get adequate nutrition into the baby. So this is the explanation to why that just occurred. And then you would go through, because the total calories should be at 116 and the total protein should be at 3.7, and we're at 96 and 3.3. And they don't sound like much, but for an 880 gram baby, that's pretty significant. And we are probably going to see this baby is not growing at the rate that we desire.
Okay, so definitely we know that we're going to need to shift things around now to try and get this baby to meet the goal.
Yes. So your recommendation should be to advance the enteral feeding.
So we would advance enteral feeding provided that the baby is doing well on enteral feeds, correct?
That's correct. And we haven't been given any information to say that they haven't. A lot of times it's just, it's a lot of work to keep advancing these babies. And so when I worked in the NICU, I had 18 babies that I rounded on each day, and there were 4 different teams. So we were very busy. And so to keep that advancement going is very, very important. And that's a primary role of the registered dietitian.
It's a big role.
Yeah. 18 babies is a lot.
Yeah.
Okay, so now we're going to take a look at the follow-up visit for this infant. So we're going to once again plot our percentiles and z-score, see where this infant lands. But before that, let's go ahead and calculate the post-menstrual age. So here we have an infant. The date is 5/22, and this is the same case study. So the birth date was 4/13. So remember that the post-menstrual age is going to be the chronological age plus gestational age. And of course, we have our gestational age from the previous slide. I'll write it in there in a minute. But first, we need to calculate our chronological age. So our chronological age is going to be the current date minus the birth date. Okay, so the current date we have here as 5/22 minus the birth date from the previous slides, which was 4/13. Okay, so we have 5 months minus 4 months, that's 1 month. And 22 days minus 13 days is a difference of 9 days. Okay, so that is our chronological age, 1 month and 9 days. But we want that in weeks and days. So we need to look at this 1 month and think, okay, where is this 1 month coming from? Well, we see that the birthday was in April, and we're currently in May. So this infant has surpassed April. Good job. So how many days are in April? We have 30. So that 1 month is going to be equal to 30 days. So it's going to give us 30 days plus 9 days for a total of 39 days. Okay? Now, of course, we need it in weeks and days. So how many days are in a week? Yes. 7. So 39. So let's think 7. How many weeks is 39 days? So 7 times 5 is 35. So that means that in 5 weeks, we have 35 days. So that gives us a leftover of 4 days. Boom. So that is our chronological age. Now we're going to do our PMA, which was that chronological age plus the gestational age, which from the previous slides, we see that was 27 weeks and 37 days. Okay, so we're going to add up the weeks here. We got 32 weeks plus how many days? 4 days plus 3 days. That's a total of 7 days, which of course is another week. So that's a total of 33 weeks post-menstrual age. Okay, and that's all we're gonna do for that. Now we're gonna take a look at the percentiles and z-scores. Again, refer back to the earlier PowerPoint or any other ones to figure out how to use PD tools. So we're just gonna write it in here. For the current weight, he is in the 26th percentile with a z-score of negative 0.63. And the previous weight from 515 this time, not 413, they were in the 22nd percentile, the z-score of negative 0.76. Okay.
Great. And before you go on and do the rate of weight gain, I just want to talk about this baby again. This is the same baby that we were slow at advancing the feeds. For whatever reason, I didn't tell you that, but now they're a month later, and they actually are no longer on parental nutrition. They are only on enteral nutrition, and I want you to notice now what the rate of weight gain is for this baby, and how important your job is at continually assessing the intake and the growth velocity to make your specific decisions of what you're going to recommend to the team and put into your A-Dime note.
Okay, so let's go ahead and figure that out then, the rate of weight gain. So remember from the earlier slides, we're going to do the current weight minus the previous weight in grams first. So we have 1.77 kilograms, which is 1770 grams, minus 1,510 grams, for a total of 260 grams. We want to divide that number based off of how many days that has surpassed, just to figure out the rate of weight gain per day, right? So from 5:15 to 5:22, that's a total of 7 days. Divide that by 7 days to give us 37.14 grams per day. But of course, we want, because of the normative data for a premature infant, we want this in grams per kilogram per day. So, excuse me, we're going to take this value and divide it by the average weight in kilograms. And of course, to do that, we add up the weights and divide it by 2 in kilograms. So we have the 1.77 plus 1.51 divided by 2, and that's going to give us approximately 23 grams per kilogram per day. And that's the rate of weight gain for this infant.
Okay.
So Janine, you want to compare that to the normative data and tell us what you think?
I mean, you didn't see my face when I saw the grams per day. I was like, whoa, that was a significant jump.
Yeah.
What was the previous weight gain?
The
rate of weight gain. Well, it was weight loss.
The weight loss, yeah. We didn't calculate rate of weight
1%.
gain. The 1%.
Yeah.
So now that
Didn't do it, but they weren't growing real well because we didn't advance feeds. But now they're growing really well. So when we look at that compared to Ziegler's data of a 1,500 gram infant, we really
it should be about 15, like between 14 to 16 grams per kilogram per day. Am I right?
16
totally
to
exceeding.
21, 16 to 21. And you had it on your second slide. So it's going to be between 16 and 18 grams per kilogram. So 1,200 to 1,500 is 18 grams per kilogram, and 1,500 to 1,800 is 16. So that's a lot, right?
So yeah, they're well above that. Yeah.
Yeah. So, and if we were to look at their BMI, I didn't have you do that, but we could have went into the Olsons and did a BMI and looked at the weight for length, but we don't have a link, so we can't do that. All right. Very good.
Okay, so we're going to figure out what enteral nutrition order this infant was on to end up with this rate of weight gain. So they were on a feeding of 27 calories per ounce at 31 milliliters Q3 hours. So once again, we are going to figure out the volume that's going to provide us. And we take our 31 milliliters, multiply it by 8, because we have 8 feedings, for a total volume of 248 milliliters per day. And we want that per kilogram, so we're just going to divide that by the kilogram of the infant, which in this case was the current weight from the previous slide, which was 1.77 kilograms. That's going to give us a total of 140 milliliters per kilogram per day. All right. Now, with that, we are able to calculate the calories per kilogram per day and the grams of protein. So again, we have our calories per ounce. We need that in calories per milliliter. Multiply that by 1 ounce over 30 milliliters to give us 0.9 calories per milliliter. All right, now we're just going to take that volume and multiply that by the 0.9 calories per milliliter. Milliliters are going to cancel, and that leaves us with 126 calories per kilogram per day. Perfect. And lastly, our protein, we have 3.1 grams per 100 calories. So that is what the Similac Special Care formula provides per 100 kcals. So with this, we're going to do another proportion, looking for the X grams of protein per kilogram per day. And we're going to divide that by what we just found to be the calories. We have 126 calories per kilogram per day. Okay, we'll cross multiply this one first. We have our 100 x kcals times the grams of protein per kilogram per day equals this little bit of cross multiplication here, which gives us 390.6 grams of protein per kilogram per day times our unit of calories per kilogram per day. Okay, so remember, we want to solve for X grams of proteins per kilogram per day. So we're going to divide by 100 kcals to get rid of that bit there. Those are out of here. So our grams of protein per kilogram per day equals 390.6 divided by 100, which is about 3.9 grams of protein per kilogram per day. And there you go.
So like right at the 4 grams.
Right there. So before we move on, I just want to reiterate something that we talked about in the previous module, that this 27 calories per ounce is not a measurement that this formula comes in. We did this by mixing equal ratios of the 24 calories per ounce and 30 calories per ounce and finding the average of that, which is the 27. And we do the same thing with the grams of protein. So if you needed that information and we didn't provide it for you, that's how you would go about figuring those values out.
Nick, before you go on to, I just want to bring some major points up as well. So on this slide, one of the first things as a dietitian, you should be comparing both the calories per kilogram to the normative data and the protein. So when we look at a baby that's 51, I think this baby is 1,500.
No, 1.77.
Oh, 1.77, thanks. Okay, so the normative data would be 128 calories per kilogram, and the protein would be 3.5 to 4.5. So you see that actually compared to Ziegler's guideline, you're actually calorically under those guidelines. This is very important because you still are going to make a judgment call. That's why I always go back to saying the baby is the one that will tell you what calories they need to be on. So if their growth is accelerated, the other thing, if we were to use Espegan, they use 110 to 130 with an average of 120. So then this would be a little bit high. But when we have a growth velocity that is 23 grams per kilogram, we really want to consider how we're going to lower that amount of intake, yet sustain the amount of protein going into the baby. So let's go on to the next slide and look at what you're going to tell us.
Well, this is what we ended up deciding as the new feeding plan that would work best for this infant. So we decided to drop the concentration a little to 24 calories per ounce instead of 27. And you'll notice we also increased the volume up just a little bit from the 31 milliliters to 33. And do you want to talk about why we didn't just do the concentration, Dr. Abel or Deneen?
Sure. The volume is what we always choose first. We always try to increase the volume first. And if they're fluid restricted or there's a reason, we would go with the concentration. But we have more feeding intolerance with higher concentrations because of the osmolality and other issues. So we tend to always, plus it is the normal route to increase the volume of intake. We're trying to get to very similar goals as a term infant. And so we're going to increase the volume first. So that's excellent. What you guys have decided to do is decrease the volume. The other thing, by decreasing I'm sorry, by decreasing the concentration, but increasing the volume, I want you to notice how they were able to keep the protein adequate, because if we did not increase the volume, we would have decreased the protein in what we were delivering to the baby. And that is very, very important to brain growth. Remember, the brain is developed in that last trimester. So we're not at term yet. So it's very important that they get adequate protein. All right, let's see what your calculations come out to.
Right, so then let's figure out what this formula at this rate is going to provide this infant based off of, and compare it to the advisable intake for their birth weight. Okay, so now we're gonna see where this infant is, whether the provided formula at this rate is going to meet the advisable intake for the infant. So the first thing we're gonna do is take the calories per ounce and convert it to calories per milliliter. As always, we have 24 calories per ounce multiplied by the 1 ounce, 30 milliliters per ounce, gives us 0.8 calories per milliliter. Okay. Now let's take a look at, well, excuse me, the fluid we see is already at 150. So that's the volume. So we know we're good there. So now that we have the volume and the calories per milliliter, let's take a look at the total amount of calories per kilogram per day. So we're going to do the 150 milliliters. That's our volume times the calories per milliliter will give us 120 calories per kilogram per day. And that is perfect. So we are right on the nose. Now let's move on to the protein. Again, here we could probably, we're going to do a proportion here. So 3.3 grams of protein per kilogram per day over 100 kcals. You might be wondering, where did I get this information? So for the protein, calcium, vitamin D, and iron here, we got this from the Similac website. And we look up this specific formula and it tells us per 100 kcals, how many of these nutrients are going to be within the formula. So for protein at 100 kcals, we have 3.3 grams. So we're going to equate this to find the grams of protein per kilogram per day, divided by the kcals that we just found to be 120. Okay, so we're going to cross multiply. And this side as well gives us 396 grams of protein. Okay, and again, we want to stick with the grams of protein per day. So we're going to get rid of the 100 kcals. And that's going to give us 3.96, or we'll just round it to 4 grams of protein per kilogram per day. So we are also right on the nose there. Now, for the other, calcium, vitamin D, iron, it's the same method. We've talked about this in the previous module, and we've worked through a ton of these before. So I'm just going to write them in here. Please work them out on your own to make sure you're getting the right answer. And of course, as always, if you have any questions, feel free to email Dr. Abel, or again, refer to our previous modules.
Okay, so let's get into our ADIME.
Yeah.
So we have really just done all of this work in our nutrition assessment, right? So we have our current weight, which is 1.77, correct?
Mm-hmm.
So we're just guys, all we're doing is just filling this out because we literally just worked all of this out.
So you're going to put your percentile and Z-scores in there too, next year. So 26 percentile and negative 0.63 Z-score.
Thank you. I did not have that available. But the previous weight was 1.51.
All right. And I have those percentiles and Z-scores too. So that was 22 percentile and negative 0.76 Z-score. You always want to include that data into your ADIME note.
Okay. And the rate of weight gain, we didn't do it as a percentage or grams per day. We did it at grams per kilogram per day.
Yeah, so just delete those units out and put it in the units that you did it in. Good job. The other thing that you would want to put on this A9 note is at the top above the anthropometric measurements, the actual birth date of 413 and the gestational age at birth. And then you would put your PMA under the current. So where a current is, you would put the date 522 and put the PMA of 33 and 07 weeks. That's just very important information. So people are acclimated to, you know, a 1.77 that is has a PMA of 38 weeks is very different than 1.77 at 30 weeks. So very
Good point.
And so, and then in the previous, the same thing, you'd put the PMA of 32 and 07 and the actual date of 5/15. Remember, these are legal documents, and you have no idea where these ADIME notes can end up.
The estimated caloric needs were about 120.
Yeah, 120 to 130 if you specifically use Ziegler. I believe it was 128, but 120 to 130 is good. That's the ESPGHAN guidelines.
And I believe you mentioned the protein intake was 3.5 to 4.5?
Yes, that would work.
Estimated, rather.
Yeah.
Okay, but our actual intake, looking back at the previous slide, we had 150.
Well, wait, that's what you're going to recommend. The actual intake was 140 mils per kilogram per day. So we did calculate what we were going to recommend, but when we first looked at what this baby was taking in, that's what you want to write here. So 140, then 126 calories per kilogram, 3.9 grams of protein per kilogram per day, 2.3 milligrams of iron per kilogram per day, and 335 units per day of vitamin D.
So that was the actual intake. So, but we should also be writing down our recommended intake. Is that right?
That'll be down in your nutrition intervention.
Perfect.
Just before we leave this slide, for this scenario, we did not have any of the laboratory values, but it is very important if you do have any laboratory values that are of significance to make sure you add that under the biochemical data.
Exactly. Or if there are procedures that would be important to your recommendations as well.
Any type of surgical procedures or anything like that?
Yes, yes. Okay, so under the food and nutrition, you can actually write the current order that the baby is on. So the EN order is Similac Special Care, 27 cal per ounce at 31 mils, Q3 hours, times 8 feedings. And we can put PN order none. But if they were on it, we could actually write in how many amino acids, dextrose. When we get next week to the complicated, you'll actually put those things in there. Mm-hmm. Client history, we don't have any history at this point, but there could have been procedures done that might be important to put in here. A lot of times we'll see neck or, something that maybe even was resolved. Most of the points that you earn for this scenario are in the ADIME note, particularly the diagnosis, the PES, the nutrition diagnosis, the nutrition intervention, and the monitoring and evaluation. So with this baby, there's actually 2 different nutrition diagnoses that you could use with this baby. We could use increased nutrient needs just because the baby is premature, so related to prematurity as evidenced by the need for nutrition support. And that would be very appropriate for this baby. So even though their growth is at the upper end or high, they still need nutrition support. And that's why we were very cautious of looking at all those nutrients like protein and calcium and iron and vitamin D, as well as the energy in the child. Another option is excessive energy intake related to the delivery exceeding the needs, as evidenced by the growth velocity of 23 grams per kilogram per day compared to the goal of 16 grams per kilogram per day. And it's really important to put those numbers in there. They make your statement more objective versus subjective. All right, and in the NICU, because we round so many times and we write so many notes, our notes tend to be much shorter and briefer. So in the nutrition intervention, we're going to just briefly go through them. So remember what our recommendation was for this little guy was we wanted to decrease the energy delivery by approximately 5%. So we're going to reduce the calories delivery, but we're going to maintain protein to slow the rate of weight gain by changing or recommending 24 cal per ounce Similac Special Care High Protein, and you could abbreviate that SSCHP. And you're going to recommend 24 cal per ounce of the SSCHP at 33 mils Q3 hours times 8 feedings.
CHP.
Yep, there you go. Some Special Care High Protein at 33 mils Q3 3 hours times 8 feedings based on 1.77 kilos. Well, you want to put what that will provide. So this will provide 149 mils per kilo per day, 119 calories per kilo per day, 3.9 grams of protein per kilogram per day, 316 international units of vitamin D, and 2.1 milligrams of iron per kilogram per day. The next statement is our rate of weight gain goal is specifically 16 grams per kilogram per day. And then we're going to recommend supplements, and we're going to recommend 100 international units of vitamin D. And depending if we had the hemoglobin and hematocrit, you could recommend 1 milligram of iron, but it would be okay not to recommend it. You could go either way, depending on the baby and the hematocrit and the hemoglobin. So those are your nutrition interventions. They're kind of brief and short, but in just a few days, you'll be making recommendations again with this baby. And then your monitoring and evaluation are very similar to what they were last week. You're going to monitor for feeding tolerance for the enteral nutrition. And you could even just write monitor and then have bullets under it if you wanted to. So feeding tolerance, growth velocity, weight daily, length and head circumference weekly. It would be very important on this baby to get a length measurement to know what the BMI is and the weight for length is. Are they growing proportionate? So is that 23 grams per kilogram and the length growing at the same rate? And that would be a very different in nutrition. And then any biochemical markers and any electrolytes, iron, protein, and bone status. And then basically you're any laboratory monitoring every week or every other week is sufficient. And there you have it. So the assignment will be very similar to what you're seeing here, an uncomplicated baby that has walked through, come off of the parental nutrition and close to full feeding and making those recommendations. Of course, if you have any questions, just let me know, and we will have another Q&A right before the assignment is due, where you can ask questions live. So thank you, and you have a great day. And thank you, Janine and Nicholas. It just wouldn't be the same without you.
Everyone, we wish you luck on this next scenario, and we'll see you next time.
Yay, bye.